Hello to the listener listening to my voice. My name is Devansh Singh, and today I'm going to present one of my project, which is known as DMS 4096 Secure Data Encryption Invention. In this particular video, I'm going to show you a little bit of concept that what is the entire project, and I'm going to show you the real world application. I'm going to show you my entire setup, that how the system really works. So let me tell you about what DMS really is. So it is an invention done by me. Basically, DMS 4096 is a cryptographic algorithm. It comes under the domain of Web 3.0, or I can say cybersecurity and network security. DMS 4096 is an encryption decryption algorithm which outperforms those algorithms which are present today and which are widely used in the terms of security as well and in the terms of speed as well. And I will prove that further in this video. So what DMS 4096 was really made of? How did this particular algorithm came into existence? So the backbone of DMS 4096 is AES cryptography. I combined AES cryptography with exclusive OR chaining, XOR chaining. I integrated cipher block chaining as well. And when I integrated all these three things, it gave me an quantum secure and faster cryptographic algorithm. So this was a basic overview about the DMS 4096. Further, let me show you how this really works. Itself suggests that the DMS 4096 works on the 4096 bit operation of the encryption and decryption technology. In this particular presentation where I'm going to prove you my project, I will be showing you two different things. First will be the entire user interface through which the user can interact with our service. And the second will be an attack simulation. I will be comparing an existing cryptographic algorithm. I will be applying a brute force attack, and then I will be showing you how that really works. So first, when I talk about my interface, it is locally hosted right now. I have not hosted it till now. So this is an user interface that a user can see when they have to test their encryption decryption algorithm. It is not a hard code. I will prove it to you right now. If I type anything over here and if I click on encrypt, you can see this encrypted data is coming over here. If I copy this particular data and when I paste it over here and when I decrypt it, it gives me a decrypted data as well. And you can see the time in which the operation has been successfully completed. Uh, if there is any doubt that the thing that I typed was hard coded, so I'm typing random keys over here. If I click over here and then click encrypt, then this is an encrypted data. Same when I decrypt the encrypted data, it will give me the initial data and the time in which it completed the operation you can see over here. Apart from this, one thing which is a good thing over here, if you want to click and see big things, if you want to click and submit an entire document and see that how it works. So I just selected a document over here. You can see it's 3ecc.docx. And if I click on extract and encrypt, I got the entire encrypted document of the paper. If I just copy it and paste it over here, and when I click on decrypt, you can see the decrypted data has been available on my screen. It and the operation completed in 0.0010 seconds. So this was the entire UI. Now I'm going to show you how the attack simulation or the security of my invention works. This video, I talked about how the security comparison is better in our algorithm when I compare it to any other algorithm. So I just made an Python based program. I'm not going to show the code in this video, but I'm going to show you how that code really works. I am comparing the DMS 4096 with a very famous cryptographic algorithm known as the AES 256. So I have given it an test data. The test data is an mixture of characters, words, and multiple things I'm going to show you right now. So if I just initialize the attack algorithm right over here, so you can see over here this particular data as you see over here. I applied the brute force on the AES 256 and similarly on the DMS 4096 as well. So when the brute force algorithm or the brute force attack initiated on the AES on that particular test data, it took 0.707 seconds to break the AES algorithm. But on the other hand, it took 5.6123 seconds to break our algorithm. So it proves that yes, our algorithm is comparatively better in performing. Over here, you can see the graph. And now let me show you the test data which I took. I'm in my attack simulation Python code over here, and this was the text which I just tested. DMS 4096. I hope you liked the project. Thank you so much.